Welcome to Savita School of Engineering video lecture series. I'm Vanathi Sriram from Placement and Training Department. Let's discuss about some computer-based technical questions. Look at the first question. What might be the answer for this first question? Is it hi or hello? If your answer is hi, then it is wrong, because here two different data types are used. One is float with the value 1.1 and another is double with the value 1.1 again. But the precision values for float and double varies. That is, for float the precision value is after decimal point there can be 6 values, whereas for double after decimal point there can be 14 values. It will substitute the precisions and it will end up with the wrong condition. That is, if the condition is wrong, then obviously the else part will be executed to print the answer hello. Here explanation is given. Whenever a float value is compared with a double value, then the value should be from the else part. That is, hello is the answer. Here there are several operators are given. This is an equal to operator to check for the equal condition. Here it is a greater than operator, less than operator, less than or equal to, greater than or equal to, and not equal to operator. We'll move on to the second question. The second question is done using a static keyword. Can you guess the answer for this? Here a static keyword is used, and to that variable var value 5 has been assigned. Once this printf statement is encountered, it will print the value 5 and then it will decrement the value of var, that is from 5 to 4. That is, in var the value is no more 5, it is 4, and here it will substitute if of var. var is nothing but 4 here, so if of 4 is a true value, so it will assume it like if of 1. That is, for true condition, the if statement will be executed. Therefore, main of means the function is called recursively. Therefore, the function main is called, and here static keyword is used, so there is no need to reassign the value 5 to the variable var. You can use the previous value, that is nothing but 4. So in printf statement, the value 4 will be printed, and after printing that 4, the value will be decremented to 3. Here you will substitute if of 3. 3 is a true value, so it will take it like if of 1 again, which is a true condition, so the main function will be called again. The value 3 will be printed, and after that it will be decremented to 2, and here it will be substituted like if of 2. 2 is a true value, so if of 1 will be taken. Therefore the main function will be called recursively again, and then here 1 will be printed. For this minus minus, var value will become 0 now. If of 0 is a false condition, therefore this function, that is the main function, is not called recursively, so that the answer is 5, 4, 3, 2 and 1. Let us look into the explanation. When static storage class is given, it is initialized to 0. The change in the value of a static variable is retained even between the function calls. Main is also treated as any other ordinary function which can be called recursively. Okay, thus the answer is 5, 4, 3, 2, 1. What is the answer for the third question? Here an extend keyword is used, and the value for an extend keyword is initialized within the main function itself. What is the answer? Yes, it is compilation error, because if you are declaring a variable using an extend keyword, then the value should not be initialized within the main function itself, whereas the value should be initialized outside the main function, like int space I is equal to 20. Let us look into the explanation. Extend storage class in the following declaration: extend space int space I specifies to the compiler that the memory for I is allocated in some other program and that address will be given to the current program at the time of linking. But linker finds that no other variable of name I is available in any other program with memory space allocated for it. Hence, a linker error has occurred. Thus, the output is linker error undefined symbol I. Now let's move on to the fourth question. What is the answer for this? You might be knowing the answer for this program if you are clear with the previous program. Here, an extern keyword is used, that is extern space out. A variable is declared with an extern keyword and that variable is printed using a printf statement, and the value for this variable is nothing but it is 100, which will be retrieved from this statement. Suppose if this statement is used inside the main function, then it would have been an error like the previous program. Now let's look into the explanation. This is the correct way to initialize a value to an external variable, that is, initialization should be done either above or below the main function. Therefore, the answer is 100. Now let's move on to the fifth question. What is the answer for the fifth question? Here, a character variable is used, that is star p, which is nothing but it is a character pointer variable, so it stores the address of some other normal variable that holds a character value. Since the variable p is holding an address, the size of the variable p is 2 here. Because whenever an address is stored in a pointer variable, it will be either a integer data type or a long integer type. Because suppose if an address like 70,000 is being assigned to the variable p, is it not possible to store that higher range of data in integer data type? So we should move on to the long integer data type. Therefore, the character star p means it is nothing but it is a pointer variable which holds an address and it is being directed to another normal character variable. So here a printf is used with 2%d, that is size of star p, and size of p is given here. For this position, that is for star p, a character value is being substituted, so it holds a size of 1 byte. So for this printf, it will print 1 here. For this size of p, it is a pointer variable, that is p is a pointer variable, and obviously it is going to store an address, so the size will be 2 for this second format specifier %d. Now let's look into the explanation. Size of operator. It is used to display the number of bytes taken by its operand. P is a character pointer and 1 byte is required to store the value and 2 bytes to store the address. Therefore, size of star p will display a value 1 because star p means it will acquire a character value. Next is size of p, which will display value 2 because p is nothing but a pointer variable which is going to hold a address. Therefore, the answer is 1 and 2. That is, for this it is printing 1, and for this size of p it will display 2. Let's move on to the sixth question. Can you guess the answer for this? Here a bitwise operator is used, that is, here a left shift operator is used and it is a bitwise operator, and whenever a bitwise operator comes, the first and foremost thing that should be done is the decimal value which is given here should be converted into a binary value, that is, the binary value for 3 should be written, and after that the shifting should be performed in the left hand side twice. Let's look into the explanation. The binary value for 3 is 0011 as last 4 bits, and the remaining bits are the MSBs will be 0. Totally 2 shifts has to be performed, that is, the bit at the second position should be moved to the third place and the bit at the first position should be moved to the second place. Like the second position bit is moved to third place and first position bit to the second place. Therefore, at the end of first shift, the bits will be 0, 110 as last 4 bits and the remaining bits will be zeros as the MSB. And during the second shift, the third position bit will be moved to the fourth place and the second position bit will be moved to the third place. Therefore, after completing both the shifts, the result will be 110 at the last 4 bits and the remaining MSB bits will be 0. The decimal value for this binary value is 12. Thus the answer is 12. And there is a shortcut for this method, that is, you should use the given number, which is nothing but 3. So 3 into 2 power number of shifts. Number of shifts is 2 here. So 2 power 2 will give you 4. So 3 4s are 12. So the answer is 12. And this is the shortcut for left shift bitwise operator. Now let's move on to the 7th question. Here a right shift bitwise operator is used, and you can apply the same condition here. Whenever a bitwise operator comes, convert the decimal number into a binary value. So write down the binary value for 3 and then perform the double shift operation. That is, the binary value for 3 is 0011 at the last 4 bits and the remaining bits will be 0. Now totally there are 2 shifts at the right hand side. First, this bit will be shifted at the right hand side and the bit at the second place will be shifted at the right hand side, that is, it will occupy the first position. Just the bit 1 is moved outside and next the second position bit is moved to the first position. Therefore, after first shift, the answer will be 0001 as last 4 bits and the remaining bits are all zeros. This bit is just deleted because it don't have any space to get occupied. And now we'll look after the second shift. This bit will be moved outside now. That is, during the second shift set, so the first position bit is moved outside now because it doesn't have any place to get occupied. So the answer after totally 2 shifts is entire 0. Therefore, the decimal value for all binary 0 is 0. Thus your answer is 0. Now let's look into the shortcut. Given number divided by 2 power number of shifts. Whereas for left shift, we have seen the formula as given number into 2 power number of shifts. Whereas here it is a division operator is used. That is, given number is 3 divided by 2 power number of shifts is 2 again. 2 into 2 will give you 4. That is, 3 divided by 4 will result with an answer 0. That is for percentage %d access specifier. If percentage %f is used as an access specifier, then we'll get some value in a rational number. Now let's move on to the 8th question. What is the answer for this? Here also a bitwise operator is used, but the number which is given there is -1. We very well know that the binary value for -1 should be written before doing the shifting operation. Whenever a negative value comes, then you should take the 2's complement of its own positive value. That is, 2's complement of 1 will give you the binary value for -1. So first write down the binary value for 1, which is nothing but 0001 as last 4 bits and remaining all the bits are 0 at the MSB side. And now take 2's complement for this binary value, that is, all the 1 will become 0 and the 0 will become 1. Therefore, we have made all the bits as 1 at the MSB side and the last bit has become 0 because 1 is given here. This is nothing but it is in 1's complement. To do a 2's complement, you should add 1 to this binary value. So if 1 is added, you will get all 1's. So -1 will be internally represented with 16 ones. Totally now we should do 4 shifts. That is, all these 4 bits will be moved at the left hand side and zeros will be added at the LSB. At the first shift, the bit 1 is moved outside, so we'll have a 0 here. In the second shift, another bit 1 will be moved at the right hand side, so we'll have another 0 here. During third shift, another 1 will be moved outside, so we'll have 3 zeros here. And during fourth shift, another 1 is moved again outside, so we'll have 4 zeros here. So you should write down the hexadecimal value for this binary value now, because a %x is used as a format specifier here. So you'll have 15 for these 4 ones, that is 8421 will give you totally 15. So the hexadecimal value for 15 is F. So you'll have F, F, F and 0 as an answer. Let's move on to the 9th question. What is the answer for this? What does this mean actually? 2 is equal to 2 minus 1. Is it possible to assign a value to a value again? This program will end up with a compilation error because a value cannot be used like this. That is, whenever a post increment or decrement or pre-increment or decrement operator comes, in that position only a variable should be used but not a value. So the answer is compilation error here. Let us look into the explanation. So it will take these two minus as minus into minus, so it will give a plus. And you should note clearly that minus minus 2 is not possible because 2 is a constant, not a variable. And whenever minus minus operator comes, it should be applied only to variables. Example, I minus minus or minus minus I. Therefore the answer is 2, that is C is equal to 2. Minus minus will become plus here and will display 2 as answer. Let's move on to the 10th question. What is the answer for this? Okay. Here a negation operator is used. What is the function of a negation operator? The function of a negation operator is to make a true value to a false value and a false value to a true value. So here we have got 16 as value, so negation of 16 will be substituted. 16 is a true value, so it will make it as a false value, which is nothing but 0. So 0 greater than 14 is a false condition. For false condition, 0 will be written. So I is equal to 0 will be considered, so it will display the value 0. Here negation operator has got higher priority than greater than symbol. So negation of I is nothing but negation of 16 is 0, that is not of true is 0. 0 greater than 14 is a false condition, so 0 will be returned. Thus the answer is I is equal to 0. Let's move on to the 11th question. Here a defined keyword is used, and wherever the square of x, this x into x should be substituted. Can you guess the answer? Let's look into the explanation. Here this square of 4 is substituted by 4 into 4, that is 64 divided by 4 into 4. Division and multiplication has got equal priority. Therefore you can complete this portion first, that is 64 by 4 will give you 16 and into 4 is nothing but 64. So the answer is 64. You should notice clearly that instead of substituting 4 into 4 here, if 16 is substituted, then it will give a different value. So whenever a hash defined keyword comes, you should not substitute the values directly here. That is, the wrong method is 64 by 16 will gives you 4. Look into the 12th question. What is the answer for this? Here again a hash define is used here. That means that wherever CLR SCR comes, 100 should be substituted. Let's look into the explanation. CLR SCR to 0 occurs, that is, the input program will be actually like this. For CLR SCR, 100 is substituted. For this CLR SCR, another 100 is substituted. You should notice clearly that 100 is a executable statement with no action, so it doesn't give any problem. Therefore, the answer is 100. Now let's move on to the 13th question. What is the answer for this? Before explaining the program, let me ask a question. Is it possible to use a variable name directly in case? Yes, it is not. Therefore, it will return a compilation error, that is, here switch of I means the value 1 will be passed as parameter, case 1 will be executed if case 2 has been given here. Since it is given as case space j, it will report a comparative error. Let us look into the explanation. Case statements should not have variable names directly, that is, the case space j is the wrong statement. Therefore, the answer is compiler error, constant expression required in function main. That is this portion. Now let's move on to the 14th question. What is the answer for this? It is not going to return any compilation error or a runtime error because the syntax is actually correct. There should be some output. What might be the answer? Let me explain. Before entering into the for loop, the checking condition is evaluated. That is, the I++ part is evaluated. The value of I will be substituted as 0 here because I++ is given here. Suppose if it is ++I, then in this place 1 would have been substituted. Therefore, in this condition part, 0 is considered. 0 means the compiler will take it as a false condition. So this entire statement is skipped. That is, here it is evaluated to 0, that is false, because I++ is a post increment operator. Now the control comes out of the for loop. Actually it is a statement here because it is entered with a semicolon. I is incremented to 1 as soon as the semicolon is encountered after the for loop. The value will be 1. Now let's move on to the 15th question. What is the answer for this? Here a while condition is checked, which is correct, that is 1 less than or equal to 5 is correct, and the value of I is printed here, and another condition is checked using an if statement, that is I greater than 2, which is not actually correct. But during the third iteration of this particular loop, the condition will become true here, that is the I value will become 3, therefore 3 greater than 2 is correct, and this statement will be executed, that is go to here, and the label for this here is explained here, printf, and hi is given here. Will it print hi? Definitely not, because the logic is whenever a goto statement is used, the explanation for that label should be given within the same function. If the explanation for that label is given outside the function, then it will not be considered as a label and it will be considered as an error. Because the logic is whenever a goto statement is used, the label definition for that particular label should be given within the same statement and it should not be given outside the function or inside some other function. Now let's look into the explanation. The scope of the label is limited to functions, that is, it should not be defined outside the functions. The label here is inside function fun, which is not visible in function main. That is, the answer is compiler error, undefined label here in function main. Thank you.